Hi, my name is Jenny Rowe. I'm here today with Dr. Krystyn Vliet. She just finished her talk, and you talk a lot about the process of cell therapy manufacturing, and it's just really promising technology. But I figured that there must be a caveat that this is a good approach for a certain disease, but some of them are not. So tell us a little bit about that.
Yeah, that's actually a really good point. So right now, not all diseases can be treated with cell therapy. Part of it is because we don't understand the diseases completely. Part of it is that cells can only do certain things well, so they can actually migrate through fluids really easily, like your blood, but they may have a hard time migrating into certain tissues. So for example, blood cancers right now with cell therapy are easier to treat than solid tumor cancers. Or cells might be able to move into a disease site, but if there's not enough oxygen there, they might not be able to actually function properly and cure the condition. So it's really a push and pull between how much do we understand the body and how much do we understand how to make cells function in that particular environment.
Okay. Cool. So you have this really exciting technology. So in terms of accessibility of that technology to patient level, what are the impacts?
Yeah, well actually for that particular spiral microfluidic device that I showed, we have that now in clinical trials for patients that have specific diseases associated with their bone marrow. And the impact is actually quite impressive. At least we don't have the human trial data yet, but at least in the animals, in that particular disease where we were trying to regenerate their blood cells that had been damaged by radiation, and then we asked, could this sorted population of stem cells be a cure? 80% of the animals survived, compared to current state of the art, only 20% survived. So we do see a huge increase in the animals. Now we hope to see similar increases in the humans.
So one of the things that's really difficult about cell therapy is the cost, right? So it's really difficult to manufacture. Does your technology going to make a difference in this cost side of manufacturing?
Yeah, that's a good question. So part of the reason why cells are expensive to manufacture as medicine is because the process is not automated, and so there's a lot of labor, a lot of people involved. It's also the reason why it's slow. So manufacturing innovation will be able to reduce the number of people who need to actually be involved in certain steps, and therefore reduce the time and the cost. But I don't want to overstate that, because the cost of cell therapy is not pegged one-to-one with how much does it cost to make the medicine. There's other factors that come in, for example, how much are you keeping the patient out of the hospital, right? But certainly by reducing what we call the cost of goods, how much money it takes to make the medicine, that will relieve the pressure and has the potential to bring the cost down. Perhaps more importantly, it has the potential to speed up how many people can receive that treatment.
Okay. So you're in this really unique position, because I feel like as a scientist, we usually try to make, one thing really great, but replicating that experience like a million times is not our strong suit, and engineers actually do that. So you're both equipped with both engineering skill as well as scientists. So tell us a little bit about that different mindset, how that makes impact in your research approach.
Yeah, that's true. So materials science and engineering and biological engineering have a lot of science involved. The goal is, as an engineer, to translate that to human impact. So when you're making cell therapy, you need the science to understand the biology and maybe to design that next potential cell therapy for that next disease. But you need the engineering to have that discipline to actually make that product turn out the same every time. So it's the difference between, say, making a custom car versus a fleet of vehicles, right? I can't just make a custom car. I can't make a boutique product. As an engineer, I have to figure out how to actually make a fleet of vehicles, and maybe there are many different colors because each person has a slightly different disease. So that challenge of being an engineer informed by the science, but really going for technology, reproducibility, measurement, and all of the data science that goes behind that, that's really fun for me.
That's great. Is there anything that you would like to add? Shout out to other things?
Well, I think one of the things that's been exciting about working on this field is working way outside my expertise with others who are clinicians or biologists or engineers of a different type, or people who run translational science, or people who the government who do regulation of these medicines, right? So I think the ecosystem around cell therapy manufacturing, the people who make the machines and the people who make it possible to work with the patients, that is a fun thing that I'm happy to give a shout out to all of the people who make it possible to bring these new technologies to people.
That's great. Thank you. Make sure to check out our talk at TEDx Beacon Street.
Thanks.